Conjugate surds. These are simply surds that are having a difference of either a plus or a minus in between them. In our example, in our illustration on our screen, we are having root of b plus c. The square root of b plus the square root of c and b minus root c. What is separating these two sides? This is a plus in between, this is a minus. These two sides are conjugate sides. One is the opposite of the other. Like we said here, root of 3 plus 7 and root of 3 minus 7. These two are conjugate sides. It's the same with these mixed sides. 4 root of 6 minus 3 root of 2. Then we have 4 root of 6 plus 3 root of 2. These two are conjugate sides. They are the same figures. The only difference is that one is a plus, the other is a minus. One is a plus, the other is a minus. Now, what happens when we multiply these two conjugate sides? When we multiply these two conjugate sides, we get what we call a rational number. Now, a rational number, remember we said, that is a number that can be expressed in form of a fraction. So this is where the term rationalizing comes from. So when we are rationalizing a surd, we actually multiply it with its conjugate. When we multiply it with its conjugate, then that process of doing so is what we call rationalizing. So right here we are having two surds. We are having this original surd, which is root of 2 plus 3. That is its surd, the surd. And we are being required to rationalize this surd. So now in rationalizing its surd, we are supposed to multiply it with its conjugate. And its conjugate is going to be root of 2 minus 3. So it's minus. That's the only difference. So it means we're going to multiply this bracket by that bracket. So it is going to be root of 2 times this, which is root times that. Then we have plus 3, plus root of 3, which is that. Root of 3 multiplied by that whole second bracket, which is this. Definitely here we shall keep opening brackets. Root of 2 times root of 2, which is this. Then plus root of 2 times negative 3, which is that. Then we have plus root of 3 times root of 2, which is that. Then we have times root of 3 times negative root of 3, which is that. Then the rest is arithmetic. Root of 2 times 2 is root of 4. Then positive root of 2 minus times negative root of 3. Positive and negative gives us a negative, so it's going to be a negative 2 times 3, which is 6. Then we have root of 3 times root of 2. They are both positive, so it's going to be positive root of 6, then minus root of 9. Because positive root 3 times negative root 3, a negative times a positive gives us a negative, so negative root of 9. And of course this and that will die, because negative root 6 plus root 6 gives you 0, so this cancel out. You remain with root of 4, which is 2, minus root of 9, which is 3. You end up with your answer being negative 1. So now negative 1 is a rational number, and so this means that you have rationalized this surd. Now you realize that from our previous example, when we were rationalizing surds, this process of multiplying a surd by its conjugate gives us what we call a product of two squares. And if you go ahead and substitute this direct, we shall get our answer direct without having to go through a lot of steps. For example, when we get this term and we multiply it by its conjugate, we create this kind of identity. And this kind of identity is what is the difference of two squares. And when two squares are multiplied, the difference of two squared is the same as a squared minus b squared. In this case, it is root of 2 minus b squared, which is root of 3, which gave us 2 minus 3, which is negative 1. So let's look at these examples. We are being required to rationalize this. Now, rationalizing this means that we are supposed to multiply it with its conjugate. So multiplying that with its conjugate is as simple as doing it like this. So this is then what we are supposed to. So we multiply this with its conjugate, which is going to be 7 root of 6 plus 9 root of 3. So when you open this bracket, it's going to be 7 root of 6 into multiplied by that, which is 7 root of 6 plus 9 root of 3, then minus 9 root of 3. Multiply that by this whole thing, which is 7 root of 6 plus 9 root of 3. So we go ahead and open brackets. When you open brackets, we multiply the whole numbers alone first. 7 times 7 is 49, times 6 times 6 is root of 36 times root of 36. Then we have this times that. So we have 7 times 9. 7 times 9 is going to be 63, so it's going to be plus 63. Then we have 6 times 3, which is 18 times root of 18. Then right here we have 9 times 7, negative 9 times 7, 9 times 7. 9 times 7 we're having 63, so it's minus 63. 3 times 6 is 18 times root of 18. Then we have negative 9 times this. So negative 9 root 3 times that is going to be negative 9 times that is going to give us minus 81, and into the square root of 3 times 3, which is 9. And definitely there, if you realize this and that are going to cancel, because positive 63 root of 18 minus 63 root of 18 is 0, so this will cancel with that. You remain with 49 times root of 36, which is 6. Then here minus 81 times root of 9, which is 3. 49 times 6, our answer here is 51. So let's do this. Now in this number I'm going to rationalize this number, but I'm going to use difference of two squares instead. So rationalizing this number, we can multiply it. We first of all multiply it using its conjugate. So it's going to be 3 plus 2 times root of 3. Multiply it by its conjugate. Its conjugate is going to be 3 minus 2 root 3. Now, using the difference of two squares, which is this, our value of A is 3, our value of B is that. So this is the same as saying 3 squared minus 2 root 3 squared. And definitely that's going to become 3 squared is 9 minus 2 root 3, this is going to be 2 times 2, which is 4 times root 3 is 3. And we end up with 9 minus 4 times 3, which is 12. And our answer is going to be negative 3. And this is how we rationalize the denominator. Up next, we are going to look into detail on how exactly we rationalize the denominator of a function. Thanks for tuning in. This has been Arnold Rangakuramia on behalf of Kisembo Academy.